Okay, we've got 51 through 54 on this. We're going to use 3 slides, so you're only seeing the first 2. Now, how do we solve these proportions? Well, what we're going to do is multiply the diagonals because we know that this times this equals this times this. So that's the first way we're going to start out. We're going to say 10 times x equals 8 times 25. And then we will simplify that into 10x equals 200. And what's happening to x? It's being multiplied by 10. What's the inverse operation of times 10? It's divided by 10. So we do 10x divided by 10. And if we do it to one side, we have to do it to the other. Divided by 10. And we get x is equal to 20. As I said, you don't need to do proofs on these. But if you did, you could plug it back into this equation here and see that it works. Or you could put it right back in here and just multiply the diagonals. Essentially, that's doing the same thing as plugging it in here. Okay. Let's do now this one. Remember, this times this equals this times this. So what we've got is y times 4 equals 24 times 12. And that simplifies to 4y equals, and I know this to be 288 because I know that 12 times 12 is 144, and this is twice as big as 12. So we're going to get twice as large an answer as 12 times 12 or 144. So that's 288. And of course then what's happening to y? It's being multiplied by 4. The inverse operation is divide by 4. And we've got 288 divided by 4, which is 72. If you're going to do calculations because you don't know how to do that in your head, that's fine, but please do the calculations off to the side. I want to see this work. This work should look like this. You should first say this times this, have these two things with the multiplication symbol in between them, and this times this with the multiplication symbol in between them, and then you simplify, and then you solve by dividing both sides, just like you're showing steps on other problems, okay? So following with that, if you get to this point and you don't know this, I should not see the work that you're doing here of this division running, like getting in the way of this work. If you need to do that, you should be doing it somewhere off on the side and having like a page of calculations so that it does not interrupt your work. All right. This is on its own slide because it has now got an expression in the numerator instead of just a single variable. So again, as always, we're multiplying this times this equals this times this. And what we get there as a result is 2 times 4 equals 8 times the expression x minus 9. And then we will have to simplify. On the left-hand side, I'm going to multiply to get 8. And on the right-hand side, I'm going to distribute to get 8x minus 72. And now I'm just solving it like a regular equation, looking at what's happening to x. It's being multiplied by 8, and then 72 is being subtracted from it. Since we're undoing order of operations and we have to go in reverse, the last thing that would have happened if we knew what x was would have been the subtraction. So we need to undo that first with its inverse operation of addition. So I say 8 plus 72 equals 8x minus 72 plus 72, and that simplifies down to 80 equals 8x. Now, dividing both sides by 8, we get 80 divided by 8 equals 8x divided by 8, or 10 is equal to x. That's how you solve it. Again, not requiring you to do proofs, but you should do a little bit of mental math to check it at least. If you plugged 10 in here, then you would get 10 minus 9 is 1. So 1 over 2 equals 4 over 8. Yep, 1 over 2 is 1/2, and 4 over 8 is also 1/2. Fun way of looking at this is to say 1 is exactly half of 2, and 4 is exactly half of 8. So we know that we're equal. Even though you don't have to do a proof, you should see that I'm starting out this way, saying the two diagonal values written down on one side with the multiplication symbol in between, and then the two diagonal values, in this case an expression and a number. Instead of with the multiplication, we have the parentheses because we need to distribute that through. So that becomes our first line. The next line becomes what we get when we simplify it, and then you have to follow all steps, show all work on the way to your solution. Okay, one more problem here. All right, I actually really like this one because it's got two variable expressions which will result in the variable on both sides. But let's start by saying this times this equals this times this, and then how can we write that? I will say 6 times the difference of 2 minus 0.5b is equal to 4 times 13 minus b. And now we're going to distribute. 6 times 2 is 12 minus, what is 6 times 1/2? Well, it's just 1/2 of 6, 3. And don't forget the variable b. On the side, we've got 4 times 13. If you play cards, you would know that there are 13 cards in each suit and 4 suits for a total of 52 cards. Okay, but you could also look at it like this. I'm going to just do this little notation over on the side. You could say 4 times 13, if you're trying to calculate that, is the same as 4 times 10 plus 3, and you can distribute through here. You can say 4 times 10, and then 4 times 3. 4 times 10 is 40, and 4 times 3 is 12, so when you add 40 and 12, you get 52. So if you can't do that multiplication in your head, you can think of it like this, and you can even write it down like that if you need to. But short answer, that is 52. Minus 4 times b is 4b. I'm going to get this work out of the way, by the way. Okay. And what can we do? Well, I like to get positive variables, so I'm going to take this. If we added 4b to both sides, we would say 4b plus this negative 3b would give us b, and that's a nice convenient result. So I say 12 minus 3b plus 4b equals 52 minus 4b plus 4b. Notice how I do this. I take everything that already exists on the left-hand side and I write it first, and then whatever it is that I'm, in this case, adding to both sides. So all of this plus 4b equals all of this, what already exists there, plus 4b. I tack that on at the end, and it makes it really easy for everyone to understand what's happening because they can look at the end of the expression that's on each side to see what's being done to it. So on the left-hand side, combining like terms, these go together to be b. So we've got 12, and is it minus b or plus b? Well, there's more positives than negatives, so it's going to be a positive b. Equals, these two are inverse operations, so they just cancel out, leaving you with just 52. And now what's happening to b? It's got 12 being added to it, so we need to do the inverse operation of minus 12. Write what's already there, and then write the minus 12. On this side, write what's already there, and then the minus 12. And you get b is equal to 40. That's it.